In the first part of Unit 5, we will be dealing with these standards, and all of these deal with functions in context, which in all reality means this. Is it linear or an exponential function? People often use functions to model real-world relationships. These functions tell us how one quantity changes in relation to another quantity. Representations of these functions, such as tables, graphs, or equations, can be used to answer questions about the relationships or to make predictions. Example 1, the Easy Car Rental Company charges a set fee plus a daily rate to rent a car. If it costs $90 to rent an economy car for 1 day and $170 to rent the same car for 30 days, write a function to model the cost of renting an economy car for X days. First question, is it linear or exponential? The relationship can be represented as total charge equals set fee plus cost per day times number of days X. The variable X is multiplied by a constant rate, the cost per day. The set fee is then added to that product. Since the rate of change is constant, this function is linear. Second step, find the cost per day, which is the slope of the linear function, and then find the set fee and write the function. So to do that, first step, 190, 170. Find the rate of change. So M equals 40. So Y equals 40x plus B. Now we got to solve for B. Choose a coordinate. I'm going to choose the first one. 90 equals 40 times 1 plus B. 90 equals 40 plus B. Subtract 40. 50 equals B. So, cost per day is 40, and your set fee is 50. And that, again, is a linear equation. Example 2, Mr. Vega bought a new car for $20,000. He used a function to estimate how its value will depreciate or decrease over time. Now, think about that for a second. Where do you remember that from? What type of function did Mr. Vega use to model this relationship? Describe the rate at which the car depreciates, then write an equation for the function. Now, think to yourself, does that look like a linear or exponential function? If you said exponential, you're correct. So let's move to the explanation. Test to see if the function is linear. Step 1. Examine the decrease in value from year to year by using the average rate of change. If the rate is not constant, this rate is not constant, therefore the model is not linear. Now, test to see if the function is exponential. Compare the value of the car in successive years. 1 year after purchase, 16 divided by 20, 0.8. 1 and 2, 12.8 divided by 16, 0.8. Between years 2 and 3, divide the 2, 10.24 divided by 12.8, and I get 0.8. That being said, each year, the value of the car is 0.8 or 80% of its value the previous year. This means the car's value is decreasing at a constant percent rate. So that means it's exponential. Determine an equation for the function, step 3. The constant rate is 80%. This is the factor by which the previous year is multiplied to get the next year. For any year X after the purchase, the year's value is given by V of X, which equals V of 0 times 0.8 to the X power. Substitute V to the 0, substitute V0, the initial value, 20. V of X equals 20 times 0.8 to the X power. X representing the year. Again, 20 was the initial value, 0.8 is the exponential rate of change, X being the year. Now, example 3. The highest possible grade for a report is 100 points. That's your initial value. Each day the report is late, the teacher deducts 10 points. Now, see if that has a constant rate of change using the rate of change formula. $90 minus 100, 1 minus 0. Negative 10 over 1. I'm going to try another one. 80 minus 90, 2 minus 1, negative 10 over 1. That means this function is linear. Now, find the equation. We already know the slope is negative 10. Now, plug in a formula. Y equals negative 10x plus b. 100 equals negative 10 times 0 plus b. That cancels out. So 100 equals b. So my slope-intercept form equation, g of x equals negative 10x plus 100. In our last example, as soon as a website went up, it received 1 hit. After 1 minute, it received 4 hits. The number of hits continued to quadruple each minute after that. This right here should tell you if it's linear or exponential. Now, let's see if it's linear. 4 minus 1 divided by 1 minus 0, I get 3 over 1. 16 minus 4 divided by 2 minus 1, I get 12 over 1. That right there tells me it's not linear. Now let's try exponential. 4 over 1 equals 4. 16 over 4 equals 4. 64 over 16 equals 4, so on and so forth. So that right there tells me this function type is exponential. And our equation would be h of x equals 4 to the x power.